Okay, in this video we're going to look at vector addition, i.e. the result of combining two vectors, one followed by the other. So in this case we're going to use two column vectors, A and B. A is a movement 2 to the right and 3 up, and B is a 4 to the right and 2 up. Now we're going to start from point A and carry out the first vector, which is a movement of 2 to the right and 3 up. So this line vector here, the yellow one, represents 2 to the right and 3 up. So if we start from point A, we'll end up here at the other end of the line at point B. So I'm going to call that vector A. We're then going to follow that by a movement of vector B, which is 4 to the right and 2 up. So this red line represents 4 to the right and 2 up. So if we start at B, move along that vector, we end up at point C. So I'm going to call that vector B. Now I'm just going to move those lines away and just replace them by two straight lines of my own, with the arrow representing the direction of the movement. Now what I'm going to now draw on is what we call the resultant vector, the single vector that represents the movement from A to C. Well, rather than going along A and then along B, I'm going to go straight from A to C, in that direction from A to C, and this vector we call A plus B. Now let's just check it makes sense. Our two vectors were 2 to the right and 3 up, 4 to the right and 2 up. So overall we'd expect to move 6 to the right and 5 up, which I'm now going to check on my diagram. So we start at point A and we go 1 to the right, 2, 3, 4, 5, 6 to the right, and now see 1, 2, 3, 4, 5 up. So 6 to the right and 5 up. I'm going to continue this explanation by looking at what the result is of having vector A and then effectively subtracting movement B. So I'm going to take a starting point down here, point A, and again I'm going to use my little yellow line to represent the vector A, which is 2 to the right and 3 up. 2 to the right and 3 up. So if I started at A, I'd end up at point B. So let's draw a little line on there and show that that is vector A. Now, very important this next bit, we're going to do minus B. Well, if we consider B to be a movement of 4 to the right and 2 up, then the vector minus B will be moving in the opposite direction. So that will then be 4 to the left and 2 down. So I'm going to put that vector on point B and we go 4 to the left and 2 down. So we end up here at point C. So let's mark that, and I'm going to label that this time minus B. It's moving in the opposite direction to B, and therefore the resulting vector, this time note here from A to C, with the arrow going from A to C, this is what we call vector A minus B. So very important there, minus B is the opposite direction to vector B. Finally, we just need to check that that movement does make sense. So we started off with A is 2 to the right and 3 up, B was 4 to the right and 2 down. So if we can actually work out the overall movement, we'd expect the final movement to be, in the end, 2 to the left, so minus 2, and only 1 up. So let's check that works on our diagram. Well, we go from A to C, takes us 1 to the left, 2 to the left, and 1 up. I'm going to finish off by looking at the resulting vector of 2A plus B. So that's two lots of movement A followed by B. So make my starting point right down here at the origin, and I'm going to start with one lot of A, which is 2 to the right and 3 up. So there's one lot of A, takes me to there. So, and then once I've got to the end of the line, I'm going to do another lot of A, so that's 2A, it takes me to this point here. So I'm going to mark that as B. So this whole movement from A to B will be 2A. I've now got to add on vector B, so 4 to the right and 2 up. So I've started there, and I end up at this point at the top here, which will be point C. and this is the vector B. So the overall movement, the resulting vector from A to C, will be this line here, and that is 2A plus B. Two lots of movement A followed by B.